Hi, I'm Jin, and I'm here to show you my dedicated cluster technology. This is a third-person, cover-based multiplayer shooter with AI. I have a pretty large map here, and it has a 3x3 grid of arenas. In each arena, we have 6-on-6 fighting going on. Now, these AI aren't especially intelligent, but they've got the mechanisms that intelligent AI would use. It's pretty sophisticated under the hood, but what they're doing with it isn't especially intelligent. But it gets the point across because I'm really not here to show you how great this game is. I'm here to show you the implementation of this technology because 6-on-6 in this arena, and I've got 6-on-6 going on in this arena over here. Like I said, they're not especially smart. Ooh, he didn't like me. You can see I got hit reactions in there. If you get hit enough, you even stumble back. Let's kill this guy. Oh, taken care of. Alright, so I got a little distracted there. I apologize. So we've got 9 arenas here, and in every single one, we have a 6-on-6 battle going. That's 108 AI running, all with this relatively heavy uh, system. On a single dedicated server, you wouldn't be able to get that many of these guys. But because I'm running a cluster with multiple UE4 servers, I can pull it off. I could take you to all 9, but I hope you can take my word for it that they're that they're all populated. Otherwise, this will be a pretty long and boring video. Switch to auto. Alright, so let me show you what's happening a little bit behind the scenes here. Okay, so here I've got 4 servers that I've rented. That is my backend server. This is one of the UE4 servers. This is another, and this is the third. On this one, I've got 4 UE4 servers all running. On this one, I've got 5 UE4 servers. Those are the 9 servers hosting the AI. So it's uh, it's got 12 on each. Over here, I have four, five, four, 4 more servers. This one here is the master. You can kind of see it's got some log messages here from when it set up the cluster. 11 workers, 2 gateways. So we've got these 9 workers here that I showed you, and I've got 2 more workers here. And those workers don't handle bots. They're solely responsible for handling the pickups. Like when somebody dies and they drop their weapon, it gets spawned on one of these servers, so they can have some CPU to handle the physics, get the reactions nice and snappy without being weighed down by all the processing going on by the AI. So I've separated the which servers are handling which objects. I also have 2. Let's see, I do have 5. I'm sorry. There's one hidden here somewhere. Let's see. There he is. All right, so we got the workers, these 2. Yeah, these 2 are handling the pickups. And these 2 are what I call gateway servers. This is where the players connect in. You can see here I have messages from the connection that I just did while I was showing you. Here's another server. I've split it up so that one server is handling the blue team players and one server is handling the red team players. In full screen mode, it's not going to look very good, but I can show you real quick that here I'm on the red team server, and you can see here now we've got that connection messages. I imagine that the video you're looking at right now is pretty choppy because recording full screen with all of this stuff going on this laptop is a bit of a heavy load. So I'm going to close this and show you the first server that we talked about. This is the backend server, and these 2 nodes are supporting the others. And that's about it from this perspective. I guess we should move on to the source code. Okay, so I want to show you the source code, but the shooter project is pretty complicated and it's not really the best place to introduce you into how this technology works. So I'm going to show you the most bare minimum demonstration that I can. And so what I've done is I've taken the standard third person template project and put it into the cluster. You can see I've got 2 clients running. Um, One of the clients is connected to one server here, and the other client is connected to the other server. And you can see that they can see each other and bump into each other. as if they're on the same server, but they're not. So what I'm going to do is open up the solution and show you what's on the inside. All right, so we're inside the solution for this UE4 project, and I think we should probably start with the game mode. The first thing you want to do when you're working with this technology is derive your own game mode from the game mode base class and do a few things to initialize my technology, which is called DAT, by the way, Distributed Actor Technology. I was going to call it Duet, Distributed UE4 Technology, Distributed Unreal Engine Technology, but there's probably some copyright issues there, so I decided to just say Distributed Actor Technology. So here we've got this function DT initialize, and that just tells the game mode, hey, time to set up the stuff that the cluster needs in order to interface with UE4, and that's really just describing this player type. So that is an enum that specifies the type. Here's your uh, actor class. Here's an internal entity class that the cluster uses. Title, don't worry about that. And this is the class that's going to be spawned, which comes from the blueprint, which we'll get into. And here is the behavior description. You know, objects, actors in the world will either just deal with collision because they don't have any awareness, or they'll be collision and vision. Visual Studio loves locking up like that all the time. All right, so you can see here that this is ATP character is this sort of C++ base class. Let's open the header. So you can see it's derived from ADT character, which is my internal class, which is itself derived from a character. So I can get my functionality in between your code and UE4. These are the functions that the cluster uses that you implement to basically handle the replication across the cluster, because at this point the technology doesn't abstract that. Got some basic things here. DT initialize is when um, a an actor is spawned on a local server, on an authority server, and duplicate is called on a remote server. Same thing with update and reflect. Update is called on the authority, and reflect is called on the remote. And these are where you want to do most of your work to replicate. The bottom here, we've just got these two functions, load and store, which are this internal entity class, and that handles the actual cluster replication, serialization. Here we're reading a byte, there we're writing a byte. That's the movement mode, which comes from the character movement component. All right, so let's run this and show you what the blueprints look like. All right, so now we're in the editor, and this scene should look pretty familiar to most of you, if you've worked with UE4 at least. Guess we'll look at the game mode first, which is surprisingly empty. I doesn't even have any blueprint code. It's because this is such a basic demo. Doesn't really need anything. All these settings are related to the cluster. And in third person character, all I had to do was add these two sets of nodes. One is an event called from dat, which tells you that you should make your actor visible or hidden. And one is whether it should be enabled or disabled collision-wise. Otherwise, everything is the same as the standard template. The only other difference, obviously, is that instead of being derived from character, this is derived from TP character, which is our class here that I showed you. And that's about it. Everything else is handled for you. Add that stuff, and you've got your cluster-based third-person template. Not very interesting, I know, but it gets the point across. I almost forgot. I mentioned this here, this ATP character blueprint class. I'll show you the declaration. It's a T subclass of ATP character, our character base class. And it's exposed to the editor. So in the editor, we can see here, and there it is, and I've set it to be the blueprint class of the player. And then everything works. So I just wanted to make that clear. Okay, so for this one, I want to show you a demo that is a little more complicated than the third person template. I've built up from that just a little bit, and I got something that's kind of neat. So this guy is capable of spawning shapes in the world. Just run through them. We've got big cube, smaller cube, and a little rectangular one. 3 sizes of cube shapes. And I've got a big sphere, medium sphere, and a small sphere. And guess what's next? Big capsule, medium capsule, and a baby capsule. Okay, so what's interesting is to demonstrate the flexibility of the cluster, what I've done is I've set up my nodes such that I've got the 2 gateways like I did before. I can connect a second client to the other gateway. You see the text move in a second. Yeah, there it is. So now he's connected here, and the first guy's connected here. Video's probably getting a little choppy right now. Sorry. There we go. All right, so now this guy's in the world too, and you can see he's there with all the objects. Um, if anyone's worked with trying to replicate physics for dedicated server, I don't know if you noticed, but there's an inconsistency problem between clients where one client will see the objects fall and the other client won't. I've got this set up, and They're identical. There's no incongruities between them. Let's see, what else can I do? Uh, yeah, I guess that's about it. Kick some balls around. But yeah, so you get the point. All right, so let's look at the code and close this cluster down. You know, I don't know why, but my shortcut hotkeys do not work when this thing is recording. Okay, so here's the game mode in this project, and you can see I've got a number of T subclass ofs. One's the character, just like it was before. The other one is for the cube, one for the sphere, and one for the capsule. Inside the initialize, you can see I'm setting them up here. Pretty much the same thing as before. And you can see that the player has collision and vision as its behavior, but the others have collision only since they don't have eyes. Here we've got a bit of extra functionality because what we're doing is when the players spawn these objects, they're actually getting spawned in the cluster. They're not getting spawned on the gateway dedicated server, which is hosting the players. It's getting spawned on a another server, a worker, which doesn't support players, just objects. So this is simple function called from blueprints, if I remember correctly. No, let's see where that's called then. Ah, I know where it's called from. Yeah, the character obviously saying, hey, spawn a cube, spawn a sphere, spawn a capsule. That's calling this function, and then it's doing what it needs to distribute the spawn. You can see it's sending over location, rotation, and scale. That's all we need. It prepares it with the size required, 2 effectors and 1 rotator, and then it says spawn the type that it was given. This is on the side, on the server that is actually doing the spawning. So it's on the remote side compared to the player's gateway server. And that just does the inverse. It reads in the data from the spawn that was sent, and depending on which entity type, it calls one of these functions, and those are the ones that are implemented in the blueprint. So ways to do it in C++, but I was really trying to show the how it makes blueprint work um, a bit easier. Maybe it doesn't make blueprint work a bit easier. Um, I like working in blueprints, and this technology allows you to deal with a little extra overhead from blueprints. You know, it's not so critical to get everything as efficient as possible because you can distribute it across servers. So there's no need to have a single server just churning away as much as it possibly can. Okay, so anyway, that's about it. This character does pretty much the exact same stuff. Except now it's doing these spawn calls. So in the blueprints, go to the game mode. Now you can see I've got some actual blueprint code here. That's it. Yeah. So this is the implementation of the things that are getting called from here. Handle spawn cube, handle spawn sphere, handle spawn capsule are here, and they're doing what you would expect. Pretty straightforward. This is just a way to get the colors to be random. Third person character, we'll have a little bit more going on in there, right? Because now we've got some input, pretty straightforward, standard dedicated server stuff, right? RPC to the server, hey, spawn this. Here, I'm just saying spawn the cubes, and I've got 3 different sizes for each of the buttons that I was pressing. On the server side, we call remote spawn cube, which we saw before. These. Same thing with the spheres, same thing with the capsules. Otherwise, this part here is just exactly what you saw in the template. Now let's take a look at the cube to give you an example. This is a little bit of a mess. Kind of don't want to explain why just yet because it's complicated, but it has to do here with client smoothing. You can see I'm saying when no client physics is true, then I'm doing this one thing. When it's false, I'm doing this other. Right now, no client physics is always false, so it's doing this stuff, but don't worry about it too much. It has to do with when you're turning collisions on and off. Visibility here is the same. It's not as pretty as what I've got here, but it works. So there's the begin play. Randomize color. Tells you whether or not you're going to use random color or standard. It's always random. I don't know why I did that. That's setting the material property. You can see if I show inherited, here's the cube base class. It's got that base color value because on the remote side you need to know what color it is in order for everybody to see objects being the same color. And the sphere and the capsule are pretty much the same thing. And that's about it for this example. Oh, actually, let's see. Here, we'll run it again. So, one, no, that's a gateway. So 80, so that, no, this one, so 7980 and 81. Each one of these servers is handling a different type of object that you spawn, right? You got the gateways, which handle the players, and then like with the shooter demo, I've got the servers responsible for different actors. One is anytime you spawn a cube, it's getting spawned on one. Anytime you spawn a sphere, it's getting spawned on the other. Anytime you spawn a capsule, it's getting spawned on the third. See here, the batch file. This starts the master. These are the backend nodes, and then we've got these first 2 are the gateways, and then you've got these parameters here which say, hey, when you're spawning stuff on this worker, don't spawn any spheres or capsules. So it's going to do boxes. On this one, it says don't spawn any cubes or capsules, so it's going to do spheres. And this one, no cubes or spheres, so it's going to do capsules. And um, so we've been, it's just a way to demonstrate the flexibility. I think that's pretty cool. And that is definitely the end of that. I just wanted to continue with this idea of the flexibility of the technology um, by showing you just how I've organized the shooter project. Here's the batch file that runs the nodes on this server, including the master. You can see it's set up to have 9 arenas and then 6 on the red and 6 on the blue. But you see here it says spawn method 1. Um, what that means is, and this is specific to the game, not the technology. The game is using the technology to do this. Um, but what it's doing is spawn method 1 says to each of the nodes handling the bots um, that each node is going to be handling a single arena. So we've got 9 worker nodes here handling the bots. And so each one has 12 bots on it, and those 12 bots are all fighting each other within the same arena. And so it's 1 arena per server, and we have 9. But let me close this down. I don't have a meta system that sets up clusters with 1 click or anything. I have to set them up one at a on each server. But let's change the spawn method to 0. Now what that means is that the bots are going to be distributed across all available nodes that can handle bots, and it's going to distribute them evenly and quite randomly. It'll be systematically assigning bots to each node, but there's no particular arena that a given node is handling. A given node will be handling bots across all of the arenas. So there's going to be a lot more crosstalk between the servers via the backend. So did I save that? Let's run this. All right, you can see the cluster coming up here. All right, they're all up and online. All right. This is starting to get into the bandwidth limitations that I have to work with at the moment, but it's still pretty good. You see, they're around 540. That's right. So you can see we've got 1, 2, 3, 4 here, 1, 2, 3, 4, 5 here, just like before. But now each node is handling bots across the entire space, not 1 node per arena. I can hop in real quick. And you should be able to see that bots are all doing what they're supposed to do. Doesn't matter that they're on separate nodes. All right, so I just wanted to illustrate how flexible the system is. That you can set up your cluster with uh, different configurations based on your needs and what works best. One thing about this method of sort of distributing the bots evenly across all the servers, regardless of location. Like I said, there's a bit of crosstalk. So you can see here that it's pushing 100, somewhere around 140, 150 megabits going out to the nodes here and here, and of course here. If I shut this down, also note it's somewhere around 50, between 50 and 60 on the receive side. So let's shut that down, and we're going to go back to spawn method one. Okay, now needs a little time to warm up, or it's not going to be a good comparison. Let's give it a second before we look. Let's see. Yeah, it's not going to go up above, somewhere around 50, 60, maybe 80. I think it might peak around 80. I forget. But it's significantly less than the 150 megabits that we were pushing before, because now we're back to a single node is responsible for all the actors at a given arena. And so there's a lot less need for the servers to know about the actors on the other servers. So there's a lot less network usage. And that's about it.